Force of gravitation. Newton observed that there is a force due to which apples fall on earth, and he also observed that there is a force due to which moon remains in the same orbit. Newton observed that this force is called the force of gravitation, and after that this becomes the law of gravitation. According to the Newton's law of gravitation, every body in the universe attracts every other body with some force, and this force is directly proportional to their masses and inversely proportional to the square of distance between their centers. Consider two masses m1 and m2. m1 and m2, these two masses are separated by a distance d. So when m1 exerts a force on m2, so this is called the action of m1 on m2. So m2 also attracts m1 with some force. This is called the reaction of m2 on m1. And these two forces, action and reaction, are always equal and opposite. So this is the Newton's third law of motion. To every action there is always equal and opposite reaction. So this force of attraction is directly proportional to the mass m1 and m2, and this force of attraction is inversely proportional to the square of the distance. After that we will write these two formulas together. F, this force of attraction directly proportional to the mass and inversely proportional to the square of distance. After that, this proportional sign we will remove with the proportionality constant g. So this g is called proportionality constant, and this is also called the universal constant of gravitation, and its value is 6.673 multiplied 10 raised to power minus 11 Newton meter square per kilogram square. This value of gravitation is very small. That is why the force of attraction between the objects and around us is very small, and even we do not feel this attraction. Since the mass of the earth is very large and it attracts the nearby objects with a great force, and the weight of any object on the earth is the result of force of attraction between the object and the earth.